packet pushers.
Hello, and welcome to the Network Automation Nerds podcast, where we explore the latest in network automation from a practitioner's perspective. I'm your host, Eric Cho, a network engineer who loves everything about network automation. Today, we're thrilled to have Phil Gervasi, a seasoned professional with an impressive background in networking, cloud technology, solution architecture, and much more. Phil is really a man of many talents and passions. He has held many different roles within the network engineering realm. He's a podcast host, technology evangelist, taught at colleges, and even at one point taught a high school English teacher. And he's an educator all in all. And we need to ask him more about that for sure. In today's episode, Phil will share insights from his diverse career, but more importantly, discuss the transformative impact of AI in network engineering and maybe just offer some good guidance for us to navigate this ever-changing landscape in the technology. So welcome back to the show, Phil. It's so great to see you again.
Thank you, Eric. It's great to see you as well. And thank you for having me.
Definitely. So last time we chat, we're mainly talking about telemetry, network observability, but today I believe we're going to switch gear a little bit and talk about AI networking, which, unless you live under a rock for the last, I don't know, a year and a half, I feel myself a bit tired of hearing about it. I don't know.
Mhm.
What are your thoughts on that?
Yeah, I think that we may be approaching the peak and descending into the trough of disillusionment, to use the Gartner hype cycle, with
Yeah.
regard to large language models in particular, not just in the tech world, but across all industries, even in mainstream media. But if you think about it, that does mean, because what happens after the trough of disillusionment, right? We go into the kind of the steady state, the plateau, where we start to actually see the real use cases, and we start to
Right.
see how the technology, whatever it happens to be, is actually truly integrated into people's lives and into various industries and their subsequent workflows. So I think that's where we are. Definitely agree. A little tired of hearing about it, but that has driven me to go even deeper in saying what's real, what's really real, and what's hype. And now that I know what's real, what can we do with it?
So unlike this bum on the other side of the screen, when I have the fatigue, I just went block it out. You went even deeper. So that's
Yeah.
fantastic.
It was very much part of my day job, in that that's part and parcel of one of the use cases that we're going to talk about today involves querying, data. So that's a big part of what network observability is all about. So this idea that it's a brand new thing is not exactly true. Certainly large language models, the way we use them today, are relatively new, literally just 2016, 2017, the advent of the transformer model and the attention mechanism. But prior to that, for many years, people were learning basic statistical analysis algorithms in second year college classes, since 1970. So the technologies that underpin what we're doing with large language models, and then what large language models can facilitate in a greater workflow, are nothing new. And so for me personally, I have been investigating and exploring the use of ML and other technologies in the data science and data analysis world to network operations, network visibility, network observability, but operations as a whole. When I say network, you could probably broaden that to IT operations, but between you and me, much more focused on the network. In one sense, yeah, kind of new, because we're looking at specifically large language models and how we can apply them. But in another sense, nothing new. It's the application of these automated programmatic processes and some sort of machine intelligence to do tasks for us, which again, we've been doing for years and years.
Yeah, I think Phil, you're one of those rare individual who could go deep in the technology as well as explain it to people. And I think that came from your background of educator and, just a community evangelist and all these impressive podcasts and, videos that you have produced. I feel like I've known you long before we actually met in person. For those of the audience that may not have, came across your work, can you just explain a little bit about your background? Just maybe give 30 seconds to a minute on how did you came about like just being an educator and
Mhm.
evangelist and to an extension AI.
Yeah. And thank you for the compliment, by the way. That was very kind.
It's all true.
So, years and years ago, I was born at a very young age. I went to college in my undergraduate work, and I just sort of chose classes that I got the highest grades in. And at the time, those were my English classes. So I was an English major, and I minored in, my minor changed often, but I was an English major, and specifically ended up focusing on, for a time, British Romanticism. So William Butler Yeats and folks like that. And then I focused on pre colonial American literature and history. So focused on some of the writings from Cotton Mather and Jonathan Edwards and those kind of folks, and then all the way into like Ralph Waldo Emerson. That was my focus, both from an academic perspective and also personally. I was very interested in that. And
Hmm.
specifically, I was interested. What happened was I went on to get my master's degree in teaching because I didn't know what else to do. So
Hmm.
all my friends that were English majors as well went to law school or went to go work at like the Gap. I don't even know if the Gap exists anymore as a store, but
It does. It does. I walk by it.
exactly. The folks went into retail or went to law school. I'm like, I don't want to do
Right.
either of those things. Law school sounds really boring and not interested in retail.
Right.
So I became a high school English teacher, teaching ninth grade, 10th grade English for a year. I taught senior English as well. And I was then going to pursue a doctoral work, specifically in a field called semiotics. This has nothing to do with tech, by the way, but this is who I am.
I was gonna say this is nowhere near networking or Cisco or
But it kind of is, though, Eric. When we get into large language models, you're going to see how this pieces together very, very well.
I like how you foreshadowing, right? Like as they say in English.
Right, exactly. So what happened was I got interested in semiotics because, I found that being an English major and then again teaching English, it was all about deciphering a text. And then there were debates, there was different philosophies and theories of language and how epistemology, how one can develop knowledge and understand what wisdom is as separate from knowledge. All these things are part of that. So it's very esoteric and there's a lot of metaphysics involved. But the idea behind semiotics is that language is the framework in which we negotiate with an objective reality outside of us. So here I am sitting in front of my screen, and there's things outside of me that I can sense. And I'm thinking in my primary language, which is English. And so if you think about it, I'm negotiating with reality through the framework of grammar rules and my vocabulary and my grasp of language. It's really, really interesting. But is that knowledge? And that's a question that folks are asking now with regard to large language models. And we're going to talk about that in a little bit. So you see how it does come full circle.
It does.
Now, I quit that because I realized I was making like 12 cents a year,
Give or take a cent or two.
give or take. And my wife, she was pregnant with our first child. And that was when I said, I got to do something different. I was off for the summer, and the head of the school there said, Hey, Phil, we need somebody to put the computer lab together. We got this grant and we got all these computers, several rooms of computers and network printers and things like that, all unmanaged switches, all dumb stuff. But it was so fun. And I had been getting kind of bored with teaching. Like, is this what I'm going to do every year? Just teach Julius Caesar over and over. And I loved it so much building those computer labs that summer that I transitioned into a help desk job, making less than I did teaching, but it was a strategic move. And I was 27 at the time.
Hmm.
And so that was almost 20 years ago. And very, very quickly fell absolutely in love with technology. And then, shortly after 6 months, 8 months in help desk, fell in love with networking specifically. What happened was over the years, though, I had a blog. Folks knew my background. So they would say, can you do like an educational video for us internally? Like this new Wi-Fi standards coming out. Can you do a video for our engineers or for our solutions architects? And I worked for VARs. So during the day, I'm out there turning a virtual and physical wrench in the hot aisle and cold aisle, very typical network engineer. And then in the evening, I would create training videos for internal, which ended up being external. And then you get plugged into the community. You know what I mean, Eric? You get plugged into folks like with the packet pushers and then Tech Field Day for quite a while. And that's kind of what happened. I love the technology that we work with. And that other side of me is still very much a part of me and has allowed me to do what I do today, specifically as a technical evangelist. And also having a love for learning, self-directed learning, which is absolutely necessary. You said that things are changing so fast. Things are happening so fast that I really wish that the entire tech world, especially with regard to AI and all this stuff, would just pause for a year. Everybody would take a sabbatical so I
Yeah.
could catch up. So I could just read the stuff and watch the videos and, catch up on some papers, get the old highlighter out, old fashioned, and catch up. Because every day when I'm starting to grasp a new concept, something new hits my feed. And I'm like, oh, all right, add that to the list of things that I don't have time to get to. It is so fun though. And that's one of the reasons I did go from formal classroom instruction to technology. So it's a double-edged sword. I love it, but my goodness, it's a pain.
Oh my God. Yeah, I wish that could happen too. You just everybody just take a deep breath and just
Yeah.
hit pause. And then so just I could catch up and
Hmm.
I'm showing you my highlighter right here. Yes, I
Yeah.
do have that as well.
Yeah.
Sometimes I love the feeling of a book. I know I'm old school and I know you brought up this foreign subject or printer back then. So
Hmm. Yeah.
But yeah, you became Network Phil, and I think that's when I actually, came across your content. And obviously, fast forward many, many years later, that, here we are, we're doing the LLMs, which, I like the fact that just like what Steve Jobs said, right? Like you can only connect the dots looking backwards. Everything fell into place. You talk about language, you talk about teaching, you talk about plug into the community. But at the time where you go through these changes, a lot of it was unknown, and now it's all falling into place. So if we would just fast forward into the present, like let's do a reality check of LLM, right? And
Yeah.
I think what we also talk about is we need to mention, as you mentioned, the technology changed so fast. At the time of recording, this is Halloween, in fact, of 2024. So whatever we say here is, pertain to what is true right now,
Hmm.
and whenever we release it early next year. So let's do a reality check of LLM, where we are today. And you mentioned the hype cycle. So are we a little bit over, a ton over? Are we still in the valley of death here or not?
Yeah. And thank you for that disclaimer. This is approaching the end of 2024. So we're saying, where are we today?
Right.
It could be very different in 2 months, just because of the pace of change, the rate of change. So are we past the peak? From a marketing perspective, yeah. From a technology perspective, no. I mean, we're building these workflows out now. In the networking space, I don't see that much being done publicly. Behind the scenes, I'm sure there is. So there's a few people like John Capobianco, who I follow, and some others that I've talked to privately that are experimenting with stuff. I just talked to Kirk Byers in Slack just yesterday about what he's experimenting with regard to large language models and networking, but not that much. And that includes vendors, although I know there are some vendors coming out with products, including my own company, products and features, I should say. So then I would say that the peak hype has occurred and folks are now settling into, all right, what's the reality here? So let's do this reality check, if I can get into it. From a technical perspective, and remember, my background now for the past 4 years, almost 5, has been in observability, which includes a lot of data analysis, the application of ML models from time to time. And that is all underpinning what we're talking about with AI, because AI is a very broad term. So what I'd like to cover today is I'd like to start with the reality check. I'd like to talk about some actual use cases that, some might disagree with me with, but that I perceive as true use cases that I'm experimenting with and that work. We could probably cover some challenges. Folks are going to talk about like, well, what about hallucinations, right? So we need to cover that.
Yeah.
What are some tools that folks can use if they want to experiment? What are some considerations if you're building something out? There's a lot to flesh out. So, it's important to remember that artificial intelligence is a broad term that refers more to a workflow, a body of technologies, and large language models is a kind of a subset of generative AI related to natural language processing. Different than general AI and the concept of artificial general intelligence, or AGI, and superhuman intelligence and all this stuff. That's another hype cycle altogether. I don't know if that's peak hype or not, but that is not what we're talking about here. Large language models definitely produce impressive results. We've all experimented with probably ChatGPT, but perhaps you've also used models like Claude or Llama, but certainly ChatGPT, being the primary in most people's minds, produces really impressive results.
And they continue to do so. Yeah.
Yep. They have no real intelligence to speak of as far as we understand human intelligence. Large language models are built on probabilistic mathematical models, which means that they use math to identify or determine or predict, to approximate what is the most likely item to come next in this sequence. And then with LLMs, we're talking about language, so it's text, words, right?
Right.
And if you ever see that output generate on your screen, you see how it outputs like line by line. If you slow it down, it's word by word. And that's what it's doing, which means that large language models are not deterministic.
Right.
Therefore, you can ask the same question or put it the same prompt in over and over and get slightly different responses because it's, again, not deterministic. Now, when it comes to hard data, we can accommodate that, but that's in essence what large language models are. Now, there are some experts that might disagree with me. They would agree with me from the technical standpoint, but there's some unknowns about how certain results occur within the hidden layers of a neural network in a large language model. And these emergent behaviors and emergent properties of the most sophisticated models that none of the researchers really predicted or expected. And so what is going on there? That's a question mark. By the way, this is one of the reasons I love this field, because there are question marks and there is a almost metaphysical component of like, what is knowledge, The idea of chain of thought and reasoning that we're hearing a lot about now with large language models, especially with the release of GPT-01. If you've experimented with that, you can expand the chain of thought window to see all the different steps that it took to get to the answer of what is 2 plus 2.
Yeah.
Is it reasoning? What does chain of thought mean? There's a lot going on there.
I love the fact that you brought up that example because for my puny brain to comprehend, and that was the example that I always think of. And it's important to differentiate that, right? Enough people say the wrong answer to steer you away from the right one. So 2 plus 2, all of us know is 4, but enough people say it's 5, then the model is actually going to steer toward the wrong answer. So given those constraints, what do you think are some of the use cases for NetOps? And we'll leave like kind of the philosophy out of it.
That's my favorite part.
And like the what is intelligent and all of that. I mean, those are fascinating discussions, I'm sure.
Well, I agree that they're fascinating, but they are important to the underpinnings of how we can apply LLMs to network operations because, again, they aren't deterministic. And again, they are based on the training data, right? And therefore, we have hallucinations. And one of the causes of hallucinations is inadequate training data or perhaps incorrect training data. So remember that these are semantics frameworks, they're language models. So when you ask ChatGPT a question about Cisco configuration and it answers you 80% correct, and you're like, oh, this is a piece of garbage. No, 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 no. It answered you. It understood your language. It just so happens to be that it was trained on all publicly available knowledge on the internet until September 2023.
Right.
That is a big deal. That means it also knows stuff about like Eric's blog and Juniper documentation and your favorite chef on TV and the transcripts from their YouTube videos. It's all there. So it's not that it's an expert in networking, it's just that it has all of that in its training data. Therefore, we do get hallucinations, we do get problems with inaccuracy. There's things in ML called model underfitting and overfitting. Perhaps the data set is too large or too small. And so it's trying to extrapolate an answer based on too little data, or it's got so much data that it's the inverse. And so those scenarios can produce incorrect results, which we call hallucinations in this field. That's not that the model is literally hallucinating, it's giving you an incorrect response that's grammatically correct. So it looks good. And then we all freak out in network operations. That's a big hurdle. So one of the things I want to talk about is how we can address that. But the real purpose here is to augment engineers, in my opinion.
Hmm.
Sure, there's conversation around automated processes using agents and agentic AI, which we'll get into, that goes beyond even just augmenting engineer. It's really augmenting the entire process. But if you think about all of the data, and this is going back to my background now in observability, all of the data that is involved in understanding what's going on with your network, right? The health of your system. You got flow logs from the cloud and from your routers and switches and firewalls, and you have metadata like site tags and customer IDs and circuit IDs, and you have SNMP information and streaming information and all your configuration files, all your stuff in your ticketing system, perhaps your emails, your knowledge base. All of those things are the things that you and I use to figure out why an application stinks going, in for my users in Chicago office. All of that stuff.
Right.
And so how do we interrogate all of that data? And when I say interrogate, I mean querying the data, not analysis, like finding patterns and correlation, but just plain old querying the data, very large, diverse, divergent data sets faster. How do we reduce the mean time to resolution, reduce clue chaining, make that less manual, more programmatic? Well, I think that that's one of the primary use cases that we can use today for large language models in network operations. So if you can imagine just using natural language to say, what is the busiest interface on all my switches in my backup data center in Kansas City, and it just goes out and finds the information for you. Now imagine that's a level 1 NOC engineer that doesn't have access to those devices, to the CLI, or doesn't know the commands, or doesn't have the domain knowledge necessarily even think of like, what should I ask? But they can just type that question in, presumably in English or whatever their language is. And then the large language model, again, being a semantics framework, not an expert in networking, can change that into a query and then go get the data for you. That's not doing analysis, by the way. And we'll get into that a little bit more later. But that is, I think, a huge benefit to just an engineer trying to get by and keep the lights on day to day. Now, how you do that, there's a lot of ways to do that. And some are much, much easier than others. But I think that's a very important and real use case and application for large language models to NetOps today.
If I may put this analogy, and I'm interested in whether you agree with it or not, is if I think of AI as an assistant who's helping me to make a decision versus as a coach who's telling me how to proceed with something. So just from what you said, I don't know if you agree that it's more of an assistant that's, you're still in charge of the final answer versus a coach. Do you agree with that? Or do you think that's a little overstatement or understatement?
Well, in this particular use case, yes, I would agree that it really is an assistant that sits alongside of your workflow.
Right.
And again, you can therefore query various data more quickly. And so you're not, writing Python scripts and SQL queries and stuff like that necessarily, and then doing it all manually, which is effective. The LLM does it for you. And again, using natural language, it democratizes information, makes things easier across your teams and across knowledge levels. And so therefore acts like an assistant, as an assistant role. However, I will say that there is a scenario, and I think it's just right around the corner for network operations, where it does start making decisions, not like a coach, but like a Rube Goldberg machine, where there's inputs and it can make some decisions, quote unquote decisions, right? And then produce outputs. And the outputs might be actually taking action, but we can get into that as well. But yeah, I do agree that this first use case is very much as a network operations AI assistant, and you can just ask questions. Some vendors out there use the term natural language query instead of natural language processing to refer specifically to this idea of querying network telemetry data. I've heard that from several vendors now.
If we could say co-pilot everywhere.
Yeah, and the thing is, the term copilot works. Like, as much as you keep hearing it, and it's like, oh, another eye roll here. But it's like, oh, actually, it is the best term for it. So I get it. And yeah, I would agree with you there.
I think one of the things that kind of scares me is every single answer, whether the model is confident or not, or like whether that how close it to the real answer, quote unquote, is every single answer appears to be 100% confident that I get back, right? But if it was human being, if it was, quote unquote, a coach or assistant, what I would hope, human in a
Hmm.
carbon life form is that it would come back to me and say, well, here's what I think is the answer. And I'm 80% confident when I'm, 90% confident. So how far do you think we're away from that world where the answer comes back and there's a percentage of confidence attached to it? Because I think that would help out a lot of us who are using it the way that you described.
We're there right now, Eric. And the thing is that it's not necessarily something you're going to see in the response from the LLM.
Hmm.
Or if you're using a tool where the LLM is abstracted by the vendor's UI, and underneath the hood, it's parsing your prompt and then passing it off to an LLM, right? That's very common. And that's great, by the way. There's nothing wrong with that.
Yeah.
You may not see a probability score or likelihood score or confidence score right there in the prompt, but behind the scenes, that is absolutely part of it. And there are ways to do that. How confident am I is not how good my model is. Although there are certainly decisions to be made about which model you're going to use for your workflow, whether it's a very large model like GPT or Claude or a smaller model like Llama, and then the various variations of Llama. So there is a consideration there. But the confidence is determined on the back end, both in pre-training to see how accurate this thing does produce results, and also in your post fine tuning and whatever other kind of retrieval augmented generation pipelines, RAG pipelines you might use, or non-RAG. And so you can mitigate error, you can mitigate hallucinations, you can limit the context that the large language model uses to generate the response, all of which increases your confidence as an engineer that you're getting back an accurate response. So all those mechanisms are used. But as far as an actual like score, that is being done on the back end. In the pre-training process, you have the process of back propagation. That is an iterative process of going through the model over and over with a predetermined result using things like a loss function and gradient descent algorithms to get that loss function within acceptable limits, and therefore confident that the model is accurate and fit for service. But that's a general purpose model. GPT doesn't know anything about your network, Eric. It doesn't know anything
Right.
about your stuff and your ticketing system. That's where the problem starts to come. And people are like, this is cool. It's fun. It helps me generate Python code, which, by the way, is an awesome use case. Like, we dismiss that offhand that, like, just writing some code, well, it doesn't do anything fancier. I'm like, isn't that awesome, though? Like, that is really helpful to me in my workflow. Decent code, usually better than I can do.
It depends on the language, I think.
Yeah, exactly. And so I think that over time, though, as we start to develop these mitigation tools and as those get improved, you're going to see the overall confidence in the results of the models, in as much as we're using them in our own workflows and not just kind of like on your laptop, from online. you're going to see confidence grow and your trust grow in the results, right? And so, for example, when you start to do something a little bit more sophisticated than just querying some data, which is awesome unto itself, it's not that it's unsophisticated.
Hmm.
If you were to do something like advanced data analysis and you start applying models to identify anomalies and to do clustering and things like that, large language models can't do that. Like in and of themselves, they can't do that. They identify, it's called semantic proximity using embeddings and vector databases, things like that. They identify how close words are to each other in vector databases in three-dimensional vector space, right? And therefore related to each other. That's actually another cause for hallucinations because sometimes words appear close to each other and they look like tables in the computer that aren't related to each other. So sometimes the word mouse, it's referring to the computer mouse or the animal mouse or the adjective that somebody looks mousy, something like that.
Oh, you look mousy.
Exactly. So you have issues with hallucinations as a result of the actual large language model itself and how semantic proximity works. So how do we overcome that? Well, when you start to get into more advanced data analysis, the large language model can't do that. So we use other tools to do that. Perhaps the large language model is just a natural language processing method. It's your UI that translates your prompt into something like a Python script that runs a pandas operation and it does other things for you. So there's an entire workflow going on that the LLM helps facilitate as far as data analysis. And now you can get back some information. Perhaps it populates a database or a table, and then the LLM in that workflow reads it and then reports back the results. Maybe it's human readable text in front of you, or you've instructed it in your workflow to produce a visualization. So you see a really nice bar graph or chart or whatever. And so the large language model is therefore like the interface between the human being and that entire process behind it of data analysis. That's another use case that I think is very, very powerful and folks are using right now. But it does presuppose that there is an entire data analysis like thing going on in your team. Does that mean you're hiring a data scientist? Does that mean that as a network engineer, we're sitting here struggling still to adopt network automation? And now you're telling me I got to be a data scientist on top of that? Come on. So it's like, well, how am I going to really do this? You're going to see vendors develop a lot of these things and put it in a package. I'm telling you, Eric, you could build this stuff in a weekend and not even a weekend. There's so many free tools out there and easy ways to get started, just not that much in network operations. And that's why I'm so excited. I think one of the reasons that it's difficult, though, is because there are some considerations for the kind of data we deal with that isn't just text data. So that's a problem that I'd like to get into in today's episode to really kind of discuss, all right, so how do we approach handling data,
I think that's a very true statement on you. Most of the time, you do it in the back end to the LLM itself in the raw format cannot. There's certainly gaps, but you fill that gap with your post processing, increase
Mhm.
the confidence level, and that usually comes in the form of a vendor tool. Both of our employers right now are feverishly trying to close that gap at the last mile. And yeah, so that's some of the challenges and some of the use cases. So let's circle back to what you were talking about on more use cases. What are some of the challenges and the way to overcome them?
Yeah, and as far as what vendors are doing, that's that whole build, borrow, buy concept that Jeremy Schulman always talks about, right?
Right.
You can build a lot of this stuff, and I am. And for me, it's more a matter of learning. You know how it is. You just get the can of Mountain Dew and your hot pocket out in the basement and just crank out the terminal until you figure things out, and it helps you to really develop a deep understanding. And that's kind of where I'm at. But would I do this in an enterprise scale? Me personally, that's a different question. And so what you're seeing is at least a few vendors. You mentioned your company, Network to Code, my company, Kentic, and I know of a few others that have teams of developers and therefore the resources and time to build this out in a much more sophisticated manner because there are some considerations and challenges, like you mentioned. So let's get into that.
Yeah.
We're talking about two major use cases. The third is like autonomous networks with agentic AI. Awesome. But that does kind of flow from the second use case, which is advanced data analysis. But these are the two main use cases, just querying data and getting back accurate results. No advanced analysis. And so that's, in my opinion, the best way to start right now. And there are easy ways and harder ways. And there are ways to get more accurate results or less accurate results, but a faster response. And then the second main pillar would be to do that advanced data analysis, but without having to know how to do it. So I just have the LLM kind of be my UI and then kick off those workflows, facilitate that, orchestrate that, if you will. One of the challenges for us is, other than what I mentioned as far as staffing, like now you have network engineers still struggling to learn Python, now also having to be data scientists, is dealing with very diverse telemetry. So if I'm just setting up an external database of text data, and then I point my LLM to that and say, hey, I'm going to prompt you, right? You restrict the LLM to answer my prompts to only that database. Well, I have just increased the accuracy of responses because it's not just going across the internet and getting random things, which, as you know, there are incorrect things on the internet.
Right.
So that's a great way to reduce hallucinations, but it's harder to do when you have very diverse data. So do you have these databases, all the data being represented by embeddings in vector databases, and you're using a system like RAG, retrieval augmented generation, to go and look at the top K chunks of data and then bring them back and use that to formulate a response, but then those chunks don't relate to each other. So one of the limitations of RAG in that sense of using it with text is that in order to actually mine through the data, what happens is that the vector database is going to chunk that data. So you think of like 100 words at a time or several paragraphs at a time, whatever it happens to be, so that it can operate with it. And so within each one of those chunks are all those words, and the large language model and the vector database understands the relationship among those words. Great. But what about among those chunks? What if those chunks are different paragraphs that all go together in a greater context? So there is a issue folks are dealing with, specifically with regard to RAG, with semantic proximity among chunks of data not working properly. And so you can get inaccurate results.
Right.
Anthropic talked about a thing in their website, some kind of announcement recently about contextual retrieval. And it's basically just adding like a header. There's a summary that the LLM adds for you to each chunk. And so now you can actually develop semantic relationships with each chunk. So there's that.
For the diverse data sets.
Correct. But that's within text itself. Now, here we are in networking. We're like, well, I got flow data.
Right.
I got structured data. I got unstructured data. I got real-time telemetry. Do I have to refresh and update my RAG database every minute? How do I handle that? If I have streaming telemetry coming in sub-second, what do I do here? How do I report on that? Do I just capture it and everything is a roll-up? I don't know. And so that's one of the problems that we're seeing with incorporating LLMs into network operations right now, is handling real-time telemetry, among other things, but also very diverse data, both structured and unstructured, kind of a semi-structured world. Hence the need for folks that are kind of like, really familiar with data science and solving these problems. And so that's a main issue. And another main issue is the whole data privacy thing, and then restricting information if you're using publicly available models. By the way, publicly available models, in my opinion, refers to the model. They're all publicly available in the sense that you download them and there they are, or run them online. But what I mean by publicly available is that it's like GPT, where they have an API that you hook into and you use their large language model. You use that framework and, you do whatever you want with it. And that's as opposed to downloading a model to your laptop and running it locally. And small models you can download and run locally. Absolutely.
Sure.
Yeah. And which means you can run that local model in a more secure fashion. And so folks are starting to do that now. Okay, what models can I run locally that are still relatively accurate to solve the data privacy problem, or if you're in medical, whatever it happens to be? But now you have a trade-off. Are smaller models less accurate? Are they not as good? Well, sometimes, yeah. Maybe you have 7 billion parameters instead of 1 trillion parameters. Does that mean that it can't produce as accurate results? Interestingly enough, the research is showing, and folks in their experimentation is showing, that if you have a smaller model that has been trained on the data that you care about, then it's actually going to be accurate within that realm anyway. It's not a general purpose model like GPT, where you're asking about anything and everything on the internet. You're only asking it about your health business or law or networking. And so, yeah, the model's way smaller, but it doesn't need to be big, number one. And number two, it's small enough where you and me, Eric, we can actually fine tune our own model, which is a very different proposition if you're talking about one of the foundational models like GPT or something like that. Or some people call them commodity models now, like general purpose models. So you can download, I don't know, let's say one of the versions of Llama that's a couple hundred million parameters, a few hundred million parameters, or Mistral 7B, what is that, 7 billion parameters, right? So these are doable, whether you have GPUs or you're using rented GPUs in like Azure AI Studio or other tools. Like Bedrock has these things hosted for you, Amazon Bedrock, so you can use them. You don't have to run them locally. I encourage that you do to experiment though. if this is something that you're looking at doing for your organization. So those are some challenges. Data privacy, ensuring accurate results. There's other ways to ensure accurate results as well. We talked about two, using a bespoke model. Some people call them small language models, by the way, because they are so much smaller. And you know what's interesting? It breaks the rules of machine learning. Remember how like model overfitting and underfitting is bad? Your data set is too small, so you can't now generalize on new unseen data. Well, actually, that works fine when all your data is so contextually constrained, So it's interesting how that happened. And so, you can use a RAG system. You can use a smaller language model that's either custom for your type of data or your specific domain. You can also fine tune a model. Fine tuning a model is not training a model like they did back in their billion-dollar data centers for 6 months. Fine tuning is adding after the fact to a already trained model additional domain data, kind of layering it on top. And then it adjusts the parameters in the model accordingly. And you can use mechanisms like LoRa and others to really adjust only the parameters you need to adjust. So it's even less of an effort. And lo and behold, you have a model that is, it's been adjusted and fine tuned for you, for your purposes on your data. But does that mean I have to do that like every day as I have new data? So again, another issue, another challenge in networking specifically. So yet another solution might be to use both fine tuning and RAG at the same time. And there's a very interesting paper that came out in June from some folks over at Berkeley. And it's about retrieval augmented fine tuning, so RAFT.
Oh, wow. So there's combining two of the solutions in the smaller model.
Yeah, it does presuppose you're using a smaller model, so you can do it on your laptop. I have an old PowerEdge R720 sitting next to me, but you have the power to do it locally or not. But you both fine tune a model, and then you can do that in an efficient way, of course. So that's an entire workflow. And you also use RAG, in other words, point to an external database to limit the context. But again, we're talking about context. How do we get truly accurate answers back when we're talking about hard data, hard metrics, right? So we're not talking about text anymore. So that's a limitation. RAG is great, but perhaps it's not the right solution for you. Another thing you can do is to simply use the large language model as your vehicle to programmatically generate an SQL query or a SQL query, and then run that against a SQL database, of time-stamped data or whatever.
So again, back into the assistant.
Yeah, it happens behind the scenes too. So now you have just enabled your entire NOC to very, very easily and quickly generate very complex queries with just typing in some stuff that they thought of, and they have no inherent memory. So, you have to come up with mechanisms so that way you can continue with your prompt in the same line of thinking, right? And that's fine. That's not too difficult to do. But surely what you're doing here is you're giving anyone that can type in whatever language, so again, presumably English, into a prompt, whatever their idea is, their question is, and it goes and gets the data for you. Data, very, very difficult and slow to do otherwise. So the way that would look, we'll stick with SQL, behind the scenes, after you put your prompt into the window, your system will pass that to a large language model, which translates that into a SQL query. And there's these things called LLM routers, right? Or however your workflow looks in Python or whatever it happens to be, takes that SQL query, runs it against your database. The database knows to send that back to the large language model, perhaps. The large language model says, I can take this and I can, maybe it's in JSON format or whatever. I don't know what you're using, but you take that and you can synthesize an actual response in human readable text or generate a visualization. All of that's in your workflow. So that's going to be in your code. But think about it. The engineer sitting there with his coffee late at night running the query, and it happens super fast. All that engineer did was type in the prompt or the question. And then, a few seconds later, or maybe more than a few seconds, gets back the response. An entire workflow happened under the hood, completely automated, completely programmatic, facilitated by the large language model. You can make that more complex. And part of that process is, now that I got this response back from my SQL query, perhaps I do that against various databases and then look for an average or find anomalies. You can do other more sophisticated things. The language model can't do it itself, but in your workflow, you're doing that and you get back your response. So that's another way to do it. It could be a simple Python script against a data frame, with a pandas operation. So any of those kind of things are very common right now and easy ways to do it. A limitation is that often, you're looking at a database, and that's fine. And it could be metrics, right? And you're going to get back very, very reliable results because it's just looking at the database and giving you back the metrics. 87% CPU utilization on said switch, right? That's not using semantic proximity there. But we have a lot of different types of data, a lot of different data sets, things that are related to each other in networking. Like when you see latency go up on a synthetic test, but then there was also a configuration change that swung BGP peers to a different data set. I don't know. Who knows? We need to connect those dots. And the large language model can't do that. So one of my coworkers and I have been chatting. He brought it up and I started researching it after, is the incorporation of, like using knowledge bases as opposed to just a straight SQL query generation or Python script generation, things like that. And so you have all of these tools, whether it's RAG or just generating some type of a query, or you're fine tuning your model, or likely it's a process of several or many of these components together to get you the results that you want. And that's really the key here. And I know you know this, Eric, because you work in software development. You got to write this out. You can't just say, let's just start playing with tools. I mean, obviously, you can just experiment. But if you have a goal, you need to write that out first. You need to write out not your workflow of I'm going to use this tool here and this tool here, and then I'm going to experiment with function calling and we'll do that. No, what is the result that you want? And what are the databases that you have in place already? If not, how do I get those databases up and running? And how do I process that data, clean it, handle null values and things like that? There's whole data processing workflow that's got to happen for this whole thing to pull it off. Those are all considerations there. You're using multiple tools and planning very, very carefully how this is going to look. Then you can plug in a particular model, a particular vector database, and you can swap them out if you find, well, it looks like every time I update the embeddings in that vector database, because I have to do it every 10 minutes because of the nature of my network, the latency is garbage. Try a different one. So go from Pinecone to Milvus or to Chroma, whatever works. You don't want to host it locally. You want to have somebody else host it. So all those things are considerations. And then you can adjust those components until you get the result you want. Perhaps it's focused completely on accuracy. Perhaps it's accuracy, but you have a little wiggle room there because you need the results back very, very quickly. And so that's where things are going with the application of this technology to network operations right now, solving some of these challenges, some of these limitations, figuring out exactly, okay, what does this look like in a real workflow? And it's really exciting stuff. And to be honest with you, Eric, every single day, I second guess myself and I Google things and I have to go to a YouTube video about okay, how does this work? And I'm always looking at not always, but I have started recently to look at some classes at one of the local universities, to audit, not to matriculate, but to audit some classes about data science and stuff to shore that up. Because for me personally, being a network engineer for many years, that component is lacking in my skill set.
I like the fact that how you kind of give us a tour underneath the hood on the different components to do it. You could do the augmentation on your rack, you could pick a smaller model, you could fine tune your model. But I'm wondering, Phil, is there a easy button here, right? So for me, it's great for me to understand all these components, but it's easier for me to go find a product or whatnot that already fits my context. So I am seeing a lot of the more specialized field in context. So Google, for example, Notebook LLM, or they come up with a model that's specifically for educators, right? So you take out some of these inappropriate stuff that are not G-rated, right? So is there an easy button for us to have all these components ready and all we need to do just swap out the model, for example, or we just put in the correct context, put in the correct prompt, for example? I mean, you are a researcher and advocate all through and through, so you're interested in these components. But for me as an user, I want an easy button, just press it and just, tweak one or two things and it will just give me the answer I want.
Yeah. So a couple of things that you could do. Number one is use some of the low code, no code options like Azure AI Studio. There's SageWorks, there's Amazon Bedrock, and all of those have menus and clicky clicky. And choose an embedding model, choose a vector database or not. It'll choose them for you. You don't have to choose your chunk size, but you can. And so you can experiment and get a little bit more in the weeds, but a lot of it's automated for you. And you can start querying data right away. The vector database is just index the data and there it is, right? And it automatically does that stuff for you.
But can I augment it with what you talked about? Can I do the rack? Can I do the fine tuning within that workflow that you just described?
Well, if you're using a vector database, you're almost certainly using RAG because the large language model that Amazon's going to use or whatever is going to use that database to augment in its generated response. So it's going to retrieve the data from that database, enrich its response or augment it, and then synthesize a response on your screen. So it is using RAG. Now, the thing is, that's going to give you fewer options, but it is a great way to start and experiment and build out really complex workflows as well. Don't get me wrong. But another thing you have to consider is what models are most appropriate for my use case. You mentioned that there are bespoke models for certain industries industries. We have OWL, OWL in tech, which some people like, some people don't, but they are part of a greater workflow. So my recommendation is that you don't get hung up on one particular piece, but you do look at the workflow, and then you can experiment with swapping out Claude for Llama, or you use GPT, or maybe you don't want to spend the money. There are differences in accuracy. There are differences in the context window size. So Claude has a 200,000 token context window, whereas GPT is 128,000. Some models are only down to 32,000. So that's limiting. Maybe it's not limiting. The other thing is, if you are using something with a large context window and you put in a gigantic prompt, which is a method, you can just drop your entire database with your prompt. Why not, right?
Every single time.
You could.
Yeah.
But there's something called lost in the middle where, it's just such a long prompt that it ends up spitting out inaccurate results because the LLM literally got lost parsing that out. I say literally, it's figuratively, but that's what's going on. We call that lost in the middle. So there are considerations. Maybe the window size isn't relevant to you. The same thing with databases. What vector database is the easiest for you? Do you want to host it? Do you not want to host it? Do you want to run it on your laptop or in your data center? What does the latency look like? How fast can you update those embeddings? How easily can you update those embeddings? What are you already using? All of those things are important. So to get started right away, you can use one of those services for sure. I also recommend that you explore the Hugging Face website. If you're not familiar with Hugging Face, it's all open stuff. So I use Hugging Face, and then I check the leaderboard to see what models people are experimenting with and all the different iterations. So if you're interested in Llama, all the different iterations are there, plus the various fine-tuned models that people will put up there. So there are hundreds of thousands of models, maybe 1 million models available right now, large language models. Some of them are small, but we call them large language models. And admittedly, some of them are just fine-tuned versions or variations where somebody copied and pasted, make a change, and then uploaded it. But that is the extent of options that you have. So check out the leaderboard. It's kind of like looking at Amazon reviews. That's what I do, at least, because I don't know any better. And then you experiment. For example, ChatGPT gives me better results than Llama,
Hmm.
but I don't want to pay for GPT, so there's a trade-off there.
Hmm.
You can also download Ollama, Ollama. That's not Llama, it's Ollama. You can download that, which is basically an application that's text-based. It's not a graphical UI, but you can run your large language model right in there. So yesterday or a couple days ago, I updated from Llama 3.1 to 3.2. It's just Ollama pull, then the model name, it pulls it down, and you're running it locally. It's compiled code. The whole 6 months of pre-training, you're not doing that on your laptop. It's compiled code. You're downloading 500 million parameters, whatever. Maybe it's 5 gigs, 10 gigs, whatever it happens to be. And then you can run it locally. So I also recommend you look at Ollama, download it. It's super lightweight, and pull your first model and start experimenting.
I think, Phil, we might want to give people a little bit of background on what Hugging Face was. And, I know this is not everyday vocabulary, especially for network engineering, right?
Well, Hugging Face is an organization that's basically promoting the community around large language models in particular, but all the related technology. And they're all over social media, and they have people submitting their own posts and stuff like that. So there is a social community there. It's also a place that hosts various models and things like that. And so you can go there where people are conversing about how they implemented a particular model. And then folks are using it as their repository as well. And so it's a repository for many models, open models, free models that you can download and play with right now without having to pay for things and think about tokenization or cost for tokens and all that kind of stuff. And so in that sense, it's, in my opinion, probably the premier place to go for those kind of resources. And when I say models, there's a lot. It's not just Llama and GPT. There's a lot of stuff you can choose from. Again, what I do is I just go by the leaderboard.
Yeah, so for me, it's almost like a combination of GitHub and Slack for data science and in particular large language models. And as you said, the contents are so diverse and vast out there that you just kind of have to trust the community's intelligence that, the best ones are going to bubble to the top. And as you mentioned, the leaderboard.
Yep.
I think it's just a fast moving field. And I know we could go on and talk forever on some of these stuff, but what are some of the considerations in addition to what you already mentioned to go next? Besides just go, download Olama, try out different models, get familiar with the workflow. What are some of the resources that you could think of and the important considerations moving forward? Like, what are some of the stuff that we could do today besides just go to the leaderboard, familiarize with us with terms,
Yeah.
which I think it's already going to take a ton of time. I know it did for me.
Yeah, well, you got to get familiar with what we're doing here in the first place. I mean, that's just part of it, and understand what these things are. But tools like Olama make it a lot easier and make life easier and things like that. And then, as far as if you do build it out, you have to choose a vector database. Don't make it complicated. Just choose a free version of Pinecone or Chrome or whatever you want. I did a podcast with Ryan Booth recently. He recommended a vector DB called Vectera. I haven't tried it, but again, they have a free version and he loves it because it's just so easy. And the reason he brought it up is because I started to get into the weeds. And he goes, his recommendation, and therefore now it's mine, I'll adopt it, is just get something working. Don't go
Yeah.
nuts. If you're already using, like, let's say ChatGPT in your workflow, which I do, work with it over time, over an afternoon, a rainy Saturday afternoon or something, to build out a very simple workflow where you use maybe Olama and a free model like Llama, right? And then point it at a CSV file on your desktop, something very, very simple like that. And then just ask it simple questions like, what was the maximum CPU utilization for all my switches, and it looks at the CSV and spits out and then experiment with how to get that more accurate. That's how I would start. Just do something simple and get it working. Then you can start adding, like, okay, how do I build a RAG system? Maybe you don't even touch a vector database for a couple weeks, things like that, even though they are pretty easy. And you don't even consider doing anything with agents and tool calling for a time. That's the long term. But getting started right now, just run a local model and point it at something on your desktop and see how you can ask natural language questions and then get back an accurate response. Because that's the whole point. We don't have to set up SQL queries, SQL queries. I say both. I always go back and forth. But you don't have to set up fancy queries and Python scripts, but certainly that can be the next. And then from there, adjust components individually, not entire big pieces. Like, don't throw your entire LangChain workflow out. Start with one piece so that you can identify where the problem is. And then, lo and behold, you're getting more accurate answers now without having to redo everything. So that, again, that's a software development thing. That's how I would get started. Just use ChatGPT sitting on your computer right now to coach you through building it, and just put in something like, how do I build a query engine using Olama and Llama 3.2 to query a CSV on my desktop? Something like that. And then boom, 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 it'll spit out some stuff. And then you start playing with it. There's a great way to start, in my opinion.
Back to your first use case, right? Being an assistant, use the existing cloud-based tools to get you started. So for me, I think there's something about building a local instance of it. I don't know what it is, right? Like, so if I just using an API or if I just using ChatGPT's web interface, it doesn't look real to me. But when I was, able to just download a local model, do something super simple and pick the worst model, right? Forget the leaderboard. Go back to the end of the leaderboard, pick the worst one, and then see that result coming back, then compare that with the good one or relatively high on the leaderboard one, then that makes a huge difference. So I think it's something to say about experimentation, making mistakes, and looking at it locally so you could understand the different component, understanding that the model is just a model. It's a binary that you download, and all the other components are the more important stuff. Anything to add to that?
Yeah, don't start with fine tuning a model. Like, don't do that right now. Like, start with just getting something to work.
Yeah.
And then for me personally, a lot of the time I end up finding something on YouTube and I'm just copying the guy, like, step by step. It's a 40-minute YouTube video, right? And I'm just following along and I got it working, but I don't really know what's going on quite yet. And there's no way I can expand it to work for my enterprise organization, but you get something working and that's really neat. Of course, it's a rabbit hole though, right, Eric? I mean, once you start going down, oh my goodness, it's a rabbit hole. And you're like, I want to try that. Well, I want to try that. Just try something and stay focused on it and make that something a simple thing. I personally think it's just a CSV somewhere local on your desktop or somewhere local, and you just point to it and start with that. But certainly the tools from Amazon and AWS and others are also really great too to build stuff out with, some clicks of a mouse.
Yeah, I think if you suffer from shining object syndrome, this is a very hard place for you, as I am. So
Yeah, for sure. I agree.
I think you gave a lot of good use cases like assistant, querying data, how we could solve some of the challenges, and you list out some of the challenges out there in today's episode. And I really appreciate you coming on. I know you kind of been living this for at least, a few months ever since, we kind of talked in person. So, thank you for coming on and share your knowledge with us. I really appreciate it.
It was my pleasure.
So where can people continue to find you? Like we said, I'm pretty sure it's outdated by the time we release it, but just how far outdated it is. So where can people find you to continue to follow your work, Phil?
Well, I'm still on Twitter, network_Phil.
Hmm.
I'm also on Blue Sky, Network Phil, no underscore. You can search my name, Philip Gervasi, in LinkedIn. And my personal blog is networkphil.com. And I do have a recent post, recent as of mid-October, right, on how to get started with LLMs in network operations that covers a lot of the stuff that we talked about today.
Nice. I didn't know you posted in mid-October, but I'll go check it out and we'll put that in the show notes. If people are interested in getting to know if hasn't been like a newly updated, version 2 out there by the time we release this episode.
Mhm.
Thanks again, Phil, for stopping by. Thank you for listening to this episode of Network Automation Nerds. Do you have any feedbacks for network automation, our guest Phil today, this episode on AI and network engineering? Please do send us some follow-ups on packetpushers.net/FU, where the FU stands for follow-up, of course. We really do want to hear from you. Check out our website at packetpushers.net to find other network engineering focused podcasts, blogs, YouTube videos, and so much more. You could find podcasts such as Network Break for weekly shows, heavy networking for deep diving into technologies like we've done today, packet protectors for security, and so much more. And we really do want to thank you, the wonderful listeners, for your support. And last but not least, remember that too much network automation will never be enough.